Welcome you all for the next session of concrete technology. That is test on hardened concrete. In that test on hardened concrete, there are different tests are conducted to measure the strength of concrete. Those are called as a non-destructive testing method. So the non-destructive methods have been in use for about 4 decades. In this period, the development has taken place to such an extent that it is now considered as a powerful method for evaluating existing concrete structure with regard to their strength and durability apart from assessment and control of quality of hardened concrete. In certain cases, the investigation of crack depth, micro cracks, and progressive deterioration are also studied by this method. Okay, so what is the crack depth which is occurred in a hardened concrete, and how many numbers of a micro cracks are there, and what is the extent of deterioration of a concrete is occurred, that we are going to measure from these tests. Okay, so I'll directly go for the first test, that is rebound hammer test. So what is this rebound hammer test? Schmidt's rebound hammer, developed in 1948 as one of the commonly adopted equipment measuring the surface hardness. The sectional view of hammer is shown below. So I think in a picture you can see that is rebound hammer. This is a hammer which is used for measuring the concrete cracks. Okay, so how to measure this with the help of this rebound hammer? We'll study that. It consists of a spring control hammer that slides the plunger with a tubular housing. When the plunger is pressed against the surface of a concrete, the mass rebound hammer of the plunger, the mass rebound from the plunger. It reacts against the force of the spring. The hammer impacts against the concrete and the spring controls the rebounds, taking the rider with along the guide scale. By pushing the button, the rider can hold position to allow the reading to be taken. The distance traveled by the mass is called as the rebound number and indicated by the rider moving along the graduation scale. So this is how the rebound hammer is there. So the instrument ready to, first picture is showing the instrument is ready to test. When you press this rebound hammer, the plunger will pull the spring inside this on the surface of the concrete. Then it measures some number on the surface. Okay, how exactly is like this? So the concrete, some cube is kept, and we are going to press that hammer. Certain extent it is going to move. The plunger is going to move at the certain extent, and after that extent it is not going to move, it will stop. At the extent where it stop, it measures some number. That number is called as a rebound hammer number. So the rebound hammer number is directly connected with the compressive strength. If the rebound hammer number is more, then we can say that rebound hammer number is more, then we can say that the compressive strength of a concrete is also more. There is a relationship between the rebound hammer and also the compressive strength. So however the rebound hammer number is increasing, the compressive strength is also going to increase. So that we can say the rebound hammer is depending, strength number is going to be related with the compressive strength. What are the limitations? Although rebound hammer provides a quick, inexpensive means of checking the uniformity of a concrete, it has a serious limitations, and these must be recognized. The results are affected by smoothness surface under the test, size and shape and rigidity of a specimen, age of specimen, surface and internal moisture condition of the concrete, type of coarse aggregate, type of cement, type of mold, and carbonation of a concrete surface. So these are all will going to affect for the rebound hammer test. So comparing to the pulse velocity method, the rebound hammer test will not give the accurate method. Okay, so that is the one test, that is rebound hammer test. Okay, and next we have one more test called as a pull out test. So what is this pull out test? A pull out test measures the force required to pull out from the concrete, especially a special shaped rod whose enlarged end has been cast into the concrete. The stronger the concrete, the more is the force required for the pull out. Whenever the concrete is doing, then some steel bar, or we are going to place some rod. So when you pull out, if it requires more force, then we can say the concrete is a good strength. If it is not required the much strength, then we can say that the concrete is weaker in condition. The ideal way is to pull out the test in the field would be to the incorporate assemblies in the structure. These standard specimen could then be pulled out at any point of a time. The force required denotes the strength of a concrete. Another way to pull out test in the field would be cast one or two large blocks of a concrete incorporating a pull out assemblies. Pull out test could be then performed assessing the strength of a concrete. Whatever the concrete we are using, that concrete cubes will be made. Whenever the cubes are made, preparing, then we are going to keep some rod in that. So what is the strength required to pull out that rod? Depending upon that, the strength of a concrete we are going to measure. So other than this, we have one more test that is called as the pulse velocity method. Ultrasonic pulse velocity method. Okay, the picture they have shown in the previous, this is ultrasonic pulse velocity test equipment. Okay, remember this picture. I'll come to the point. This can be subdivided into two parts: mechanical sonic pulse velocity method, ultrasonic pulse velocity method. So we commonly use the ultrasonic pulse velocity method, which involves the measurement of time of travel of electronically generated mechanical pulses through the concrete. Okay, ultrasonic pulse velocity method consisting of the time of travel of an ultrasonic pulse passing through the concrete to be tested. The pulse generator circuit consists of an electronic circuit for generating the pulses and the transducer for transforming these electronic pulses. Okay, it consists of a electronic circuit for generating a pulses and a transducer for transmitting these electronic pulses. Whatever the pulses which are produced, that has to be supplied, that is supplied through the transducer into mechanical energy having an vibration frequencies in the large range of 15 to 50 kilohertz. The time of travel between initial onset and the reception of the pulses is measured electronically. The path length between transducer is divided by the time of travel gives the average velocity of the wave propagation. Recently, the battery operated fully portable digitized unit have become available in a UK. One of such is called as a Pandit ultrasonic digital tester. The text of measuring pulse velocity through the concrete. Direct transmission, indirect transmission, and surface transmission. The factors affecting the measurement of pulse velocity is smoothness of a contact surface area under the test. It is important to maintain a good acoustical contact between the surface of a concrete and the face of each transducer. Generally, this does not pose any problem because of the normal testing. Sufficient cast surfaces are available for good contact. However, when it is necessary to hold the transducer against unmolded surface, for example, the top surface of a test cylinder is desired to be smooth the surface by the use of carborundum stone, and the transducer should be held tightly against the concrete. And influence of path length on the pulse velocity, temperature of a concrete, and moisture condition of a concrete, presence of reinforcing steel. Everything will be affect to the pulse velocity method. So how it affects, you just go through that. Applications: It is used in uniformity of a concrete, establishing the acceptance criteria and measures whether the concrete is of a good condition or not. So the pulse velocity is measured in meter per second. If the pulse velocity is 4575, then we can say that excellent concrete. If the pulse velocity is 36604575, then it is good. And if it is 2135, then it is called as a very poor. So like this, based upon the pulse velocity, we are going to measure the strength of a concrete. And how this pulse velocity technique is done is have been used to measure. This is successfully used for the measurement and detection of a cracks also. The basic principle of a crack detection is that if the crack is appreciable width and the considerable depth perpendicular to the test path, no signals will be received at the receiving transducer. When you are keeping the pulse that's current circuits, then if there are a cracks, then we can see no pulses and the transducer. If the depth of the crack is small compared to the distance between the transducer, the pulse will pass around the end of the crack and the signals will be received at the transducer. However, in doing so, it would have traveled the distance longer than the straight line path upon which the pulse velocity computations are made. The difference in the pulse velocity is then used to estimate the path length, and hence the crack depth is measured.